Algebra 2. This week, basically, I don't know if you were in the green book, hello, for Algebra 1, but we're basically covering all of Chapter 7 in a 40-minute lesson. And because we're still in review, so that's the good news, we're still doing review, but you know, the bad news is we're squishing it all into a very short lesson. Is a lesson that I use in my Algebra 1 for wind problems, because there are going to be wind problems in this week's homework. This key is on mixture problems. We've already covered, I gave you another handout before on rate problems. It's a very similar structure. You set it up in a very similar way. This is a worksheet I have my students do, but it's the key for it. Now, if you go into my school loop, who's been to the school loop page? Okay, there are two things. There's a PowerPoint on how to do these, so you really should go watch that. And then there's a PowerPoint on how to graph systems of inequalities. We're going to talk about it today, but you really should go watch the PowerPoint. Because I couldn't squish all of this content into a 40-minute lesson, there are there's a couple of extra things. The PowerPoints won't take long for you to go through, but I strongly encourage you, and I will try to demo that for you. Okay, so the notes. Today we're going to talk about systems of equations. Every bit of this should be review except for a tiny bit of the vocabulary. Systems of equations and systems of inequalities, and graphing both. And I've tried to give you kind of a summary that'll help make sense of all of it. So this should ring a bell. The way we're talking about it, the terminology might be a little different, as you've seen in Algebra 2 with all this review. Sometimes it's the same material, but we're using slightly different terminology now in Algebra 2. So transformations are the things we do to equations as we're solving equations or systems of equations to change the equation, one or both or all of the equations in the system. Okay, so replacing an equation with an equivalent equation. Okay, that could be multiplying both sides by 3. Subtracting 2 from both sides. That's replacing an equation with an equivalent equation. You've done that. Substituting an equivalent expression for a variable in the equation. When you guys solved systems in Algebra 1, I don't know. Okay, so we have y equals 2x. We're going to do substitution. 2x, y equals 2x, that's problem number 1. And then 2x plus 5y, right, equals negative 12. 2x plus 5y equals negative 12. So, the substitution method, which I'm sure you remember, you take, if this is solved for one of the variables and it's solved for y, you can take this expression and substitute it in for y. So then I have 2x plus 5 times 2x equals negative 12. Okay, well that's 2x plus 10x equals negative 12. That's 12x equals negative 12. So x equals negative 1. Now I'm not done, because now I need to know what y is. I need to solve for both variables. So I'm going to plug this x back into either one of my original equations. You have to use the original equations. So I'll use this one because that's easy. So y equals 2 times negative 1, which is negative 2. So we get negative 1, 2, whoops, negative 2. That's our ordered pair. And that's the solution for that system of equations. Now, if you'll recall, there are 3 possibilities for 2 lines. If you have a system of linear equations, so 2 lines. 3 possibilities. You could have one line like this and another line with a different slope like this. And the intersection is the solution. So we know, because we got one solution, that these must have different slopes and they intersect at one point.
Why would it be negative 1, negative 2?
Negative 1, negative 2.
Oh, okay. Sorry.
Because I had x and y, you got it? Okay, good. Now the other possibility for two lines is that they're parallel. In which case, how would you describe the slopes? If you have parallel lines, how do their slopes compare?
They're the same.
Same slope. Okay? So if they have the same slope but different y-intercepts, then they're parallel lines. What will be the solution here?
No solution.
No solution, because these lines never meet. That's the definition of parallel lines. They're in the same plane and they never meet. So if you have parallel lines, you know, this obviously wasn't parallel because we got a solution. Then you'd have no solution. And then the other possibility for two lines, so we had one situation where they have different slopes, which means eventually somewhere along the line they're going to intersect. Or parallel, the other possibility is to be the same line. Okay, I'm not putting arrows on it, but there we go. So if they're the same line, how many solutions are there? Infinite. Every single point is a solution. So we have one solution, no solutions, or infinite solutions. This should ring a bell from Algebra 1. Okay, yes?
How do you graph it from the equation?
From the equation, we're going to do that. Okay? And we did some of that last week too, where we showed the most efficient way to graph each type of line. Like this is in slope-intercept form, so you have a slope, and in this case your y-intercept is 0 because there's nothing there. So you put a point at 0 and then use the slope to get a second point. In this case, it's in standard form, so you could find your x and y intercepts. But we're going to do a little more of that today. Well, assuming. I may be drawing the graph on the board, but we'll do our best. So let's do the second problem here, the other substitution problem. So we have x minus 2y equals 2. They're all buzzing out there. That's funny. Negative 2x plus 5y. Let me make sure I'm getting this. It's dark, so and I'm blind. Equals negative 3. Okay. Now, the instructions were to use substitution. And if you notice, problem 3 is the exact same problem, but we're going to use a different method. But this time the instructions say use substitution. Well, I can't use substitution until I solve this, or one of these, for one of the variables. The easiest one is the one where I have just one x, so all I have to do for this is add 2y to both sides. So I get x equals 2y plus 2. Now I have an expression that I can substitute in for x in my second equation. So I'm going to put negative 2 times my 2y plus 2 plus 5y equals negative 3. So then I'll use my distributive property, negative 4y minus 4 plus 5y equals negative 3. Okay, now I have negative 4y plus 5y. That's y. That's 1y. Minus 4 equals negative 3. So if I add 4 to both sides, I get y equals 1. Now, if I plug the 1 back into my, I'll use this because it's identical to the original equation. If I plug 1 in here, I get x equals 2 times 1 plus 2, which is 4. So my solution is 4, that's my x, and 1 is my y. That's my ordered pair, that's my solution. So again, I know these are two intersecting lines. They're not parallel or the same line, yes?
It'd be the same answer if you did it to the first equation?
Yeah.
Okay.
Yeah. So you get the same answer either way.
Wait, how do you know that they're not parallel?
Because if I get a point, that means I have intersecting lines. If the solution is a point like this, that means they're intersecting, so they don't have the same slope. And we'll talk about that. So don't worry too much because we're going to clarify that. Okay? If they were parallel, then I would have gotten something in here that didn't make sense, like 3 equals 5, or something that was what we call inconsistent, an answer that doesn't work. And that's my clue that there's no solution, and my clue that they're parallel. Okay, but we'll look at that, so don't worry. Okay, so that's substitution. And usually what you can do is use any method you want, but sometimes you look at the system of equations and you think, oh, it's easiest to use substitution here. Sometimes it's easiest to use linear combinations, which is 3 and 4. So you have x minus 2y equals, this is the same, I should have left it up there. X minus 2y equals 2. We're going to do the same one, but this time we're going to use a linear combination, and you'll see that we get the same result. Equals -3. So linear combination, sometimes they call this the elimination method. You're eliminating one of the variables. So what you need to do is multiply one or both of the equations by some number, which gives you an equivalent equation. And you do it in such a way that then when you add the equations together, one of the variables goes away. Okay, so I can tell if I multiplied everything here by 2, then when I add these together, I'd have 2x minus 2x. And so that's 0. Then I'd have my equation just in y. And then I could solve for y and then go back and solve for x. So I'm going to multiply this whole equation by positive 2, because then it'll be the opposite of this. So I can do that and get an equivalent equation. 2x minus 4y equals 4. I multiplied every single term by 2. And then this one I'm just keeping the same. I have -2x plus 5y equals -3. If I add those together, my x's go away. And then I get y, 1y, 5y minus 4y, equals 4 minus 3 is 1. Oh, that's what we got before. Okay, then I can take that, plug it back into either one of these, and solve for x to get my x. This should be ringing a bell from Algebra 1. Okay, so you plug it back in, you get, I'll do the first one, x minus 2 times 1 equals 2. So x minus 2 equals 2, so I'm going to add 2 to both sides, x equals 4. So once again, my ordered pair is 4, 1, but I got to it using a completely different method. Now, why don't you guys try number 4?